All right, today's lesson, we're going to be going over the quadratic formula, okay? Which is a formula that gives us the solutions to any quadratic function. It's not the, what's the word? It's not going to be like your go-to method, but there are some quadratics where it's really the only way to get the solutions, okay? And so we're going to get the quadratic formula by first looking at this quadratic in standard form, ax squared plus bx plus c. And we're going to find the solutions by completing the square. Okay, so just a quick recap. When we're looking for solutions, that means that we are really solving for the zeros, right? And so I'm going to take ax squared plus bx plus c. We're going to set it equal to 0. Now, in order to complete the square, we need to take this c and move it over there, right? And we need to get this x squared to be by itself. We want to get rid of the coefficient. So I'm going to subtract c to both sides. I get ax squared plus bx equals negative c. And I'm going to divide everything by a. So this is going to leave us with x squared plus b over ax equals negative c over a. Now when we complete the square, we take half of our middle coefficient, square it, and add that square to both sides, right? And so half of b over a is going to be b over 2a, right, squared. So I'm going to go ahead and add that to both sides, b over 2a squared. Okay, I know it looks a little weird, but try your best to follow along. Okay, I promise at the end it's all going to work nicely. So what ends up happening is this is now a perfect square. We've completed that square. So this can be factored to x plus b over 2a squared. A squared plus 2ab plus b squared. And I'm going to rewrite this as b squared over 4a squared minus c over a. I just reversed the order here because I wanted that negative to be a subtraction sign, okay? So now on the right, we're subtracting these fractions, which means we need a common denominator. So if I want this a to match this 4a squared, I'm going to multiply it by 4a, and whatever I do to the bottom, I have to do to the top, right? Denominator and numerator. So this is going to give me x plus b over 2a squared is equal to b squared minus 4ac in my numerator all over 4a squared. Okay, so now we have a perfect square, so we're actually going to take the square root. We're going to take the square root of both sides. So we can't really take the square root of this numerator, but we can take the square root of the denominator, right? And so this is going to simplify. I'm going to continue this up here. Whoa. So we've squared this, so this is just x plus b over 2a. And this is equal to plus minus the square root of b squared minus 4ac, because we can't simplify that. But we can take the square root of the denominator, so we'll go ahead and leave that as 2a. So all that's left is to get this x by itself, so we're going to subtract b over 2a. If I subtract b over 2a, thankfully, these are common denominators, right? So we can just combine our numerator. And so I'm actually going to put the negative b first. So we end up with x equals negative b plus minus the square root of b squared minus 4ac all over 2a, okay? Now, why did we do all that? Well, because we looked at a general quadratic function and complete the square, we can see that any quadratic function in standard form, if I know the a, b, and c values, if I plug that into this formula, it's always going to give me the solutions, right? And when I say solutions, these x values are by my parabola. These are my solutions, right? And so this is going to tell me exactly where those two things are. And if you think about this, right, negative b over 2a, that looks familiar, right? Because that is our axis of symmetry. So the negative b over 2a tells us the middle of our graph, right, where our vertex is, and the plus square root of b squared minus 4ac is giving us 1, 0, and the minus is giving us the other 0, okay? So that's the quadratic formula. The solutions of ax squared plus bx plus c equals 0. When we're solving this, where a doesn't equal 0, the solutions are negative b plus minus square root of b squared minus 4ac over 2a. Cool? Now, in this formula, we have something called the discriminant, okay? The discriminant is the part of the quadratic formula that is under the radical sign. So this b squared minus 4ac is what we call the discriminant, okay? And the discriminant actually tells us how many solutions this quadratic function will have, okay? So if the discriminant is greater than 0, if we have something under here that is greater than 0, then we know for a fact that we're going to have two real solutions, okay? So if it's greater than 0, we have two real solutions. Sounds weird, okay? Now, if this equals 0, if the discriminant is equal to 0, that means we're not going to really add or subtract anything, right? Because the square root of 0 is just 0. That means that we don't have two solutions here, but if the discriminant is equal to 0, we have one real solution. And if we get this square root and it ends up being less than 0, right? If this discriminant is negative, we can't take the square root of a negative number, so we have no real solutions in that case. So this is helpful, right? We can kind of predict the number of solutions by just looking at that discriminant, b squared minus 4ac, okay? Now, it's worth noting that if the discriminant is a perfect square, right, that means we're not going to have these weird square roots that we can't simplify. So if a discriminant is a perfect square, that means that equation is factorable, right? And which in that case, you wouldn't use this formula, you would just factor and solve for the zeros. But the good news is that this formula works for all quadratic functions. Okay, so we're just going to look at a couple examples. Let's look at this one. X squared plus 2x minus 24 equals 0, right? So we can clearly see that a here is equal to 1, b is equal to 2, c is equal to negative 24, okay? So we're just going to plug these values into our quadratic formula. So if we know that x is equal to negative b plus minus the square root of b squared minus 4ac over 2a. Whoa, not a triangle. Whew. Over 2a. This is going to give us negative 2 plus minus the square root of b squared, so 2 squared minus 4 times 1 times negative 24 over 2a. So let's go ahead and simplify our discriminant. We get negative 2 plus minus the square root of 4, right? 2 squared is 4, minus 4 times negative 24 is negative 96. Okay, over 2a. So that minus a negative 96 is the same thing as plus. So this becomes a square root of 100. Okay, so a couple things, right? Just by looking at this, we know that we're going to have two solutions because this is positive, right? And if our discriminant is positive, if it's greater than 0, we have two real solutions. And we're also going to see here that this is a square root of 100, which is just 10, right? I'm sorry, I forgot to put the 2a. A is 1. So this just becomes 2, right? So negative 2 plus minus 10 over 2. That means x is equal to negative 2 plus 10 is 8. 8 over 2 is 4, right? And negative 2 minus 10 is negative 12 divided by 2 is negative 6. So we know that x is equal to negative 6 and 4. Cool beans? And like I said, because this is a perfect square, this is actually factorable, right? We know that this can be factored into, well, product of negative 24, sum of 2. That's going to be x minus 4, x plus 6 equals 0. And so in this case, you would, if you saw this quadratic on a test and you were solving it, you would definitely factor it. And you can go from here straight to here without doing this quadratic formula, okay? But right now, today's lesson is just getting used to the quadratic formula. This is something you're going to want to memorize. I know it looks like a lot, but I promise there are plenty of songs on YouTube and stuff. You're going to get it down, okay? Now, it's important, in this example, right, it's not in standard form yet. So before we apply the quadratic formula, we have to add that 4. Let's do red. To get it where it's equal to 0, okay? So, real quick, this is a perfect square, right? And so some of you guys might be ahead of me and see that this is x plus 2 squared that you can solve by factoring as well. But I just want to illustrate the quadratic formula again. So we get negative b, x is equal to negative b, negative 4, plus minus the square root of b squared, so 4 squared, minus 4 times a, which is 1, c, which is 4, all over 2a. Now, 4 squared is 16. 4 times 4 is also 16. So 16 minus 16 is 0, which means here that my discriminant is equal to 0. Which means if I add or subtract 0, it's not going to change this, right? So this actually only has one solution, negative 4 over 2, which is just negative 2. So x is equal to negative 2, which means that this quadratic has one x-intercept, one solution at negative 2, which means this is also my vertex, that x-intercept, okay? And if you factored this, you would have gotten x plus 2 squared equals 0, which gives you the same solution, okay? Alrighty, let's look at this last one. So we're going to get this in standard form again. So I'm going to add that 15 because you want it to be equal to 0 because that's what a solution is, right? When it's equal to 0. So 3x squared minus 2x plus 15 is equal to 0. So in this case, a is 3, b is negative 2, c is 15. So let's go ahead and plug that into our quadratic formula. X equals negative 2, negative b, right? Plus minus the square root of b squared, negative 2 squared, minus 4 times a, which is 3, minus c, which is, not minus, sorry, times c, which is 15, all over 2 times 3. So as we start to simplify this expression, we get 2 plus minus the square root of negative 2 squared, which is 4, minus 12 times 15, which is 180, all over 6. So before we continue, you might notice what's going to happen here. Let's always pay attention to what's happening in our discriminant, right? Or to our discriminant. 4 minus 180. That's going to be a negative number, and so automatically I know that this has no solutions because you can't have the square root of a negative number, right? Negative 176 over 6. This right here means no real solutions. So our solution here is no solutions, right? And this is important. This doesn't mean that our quadratic is broken or doesn't work or doesn't exist, right? But no solutions means that we don't have any zeros. So in this case, it might look something like this, where maybe if my vertex is here, right, it would open upwards and never end up hitting the x-axis, right? Still a parabola, still a quadratic, just doesn't have any solutions, okay? This example here, my quadratic has one solution at negative 2, right? Which means that it's also the vertex. And in this case, we have two solutions one's at 4, one's at -6, which means my vertex is somewhere right in the middle at -1. So if it was something like this, but hopefully you get the idea. 2 solutions, 1 solution, no solutions. Okay. Now in this no solutions case, that -176 means if I went to go and try and factor this, I wouldn't be able to, right? If we kind of just look at this right here, I would be looking for a product of 45 and a sum of -2, and that just, there are no numbers that work that way, no integer factors that give us those answers. So this is a good way to check, right? If you're trying to factor something and you find that you can't factor it, plug in, use the quadratic formula to check if they have any solutions, all right? So your homework tonight is going to involve just using this formula to either determine the number of solutions or actually find the solutions. Cool. All right, that's it. This is actually going to wrap up our unit. So we'll probably look at some application problems, but this is like the end of this class, which is kind of sad.